All right, welcome to Lecture 12. And in Lecture 12, we're going to learn about this concept called the mole. So what the heck is a mole? It's not this thing. It's not the guy who tears up your yard, even though he kind of looks like it, right? It is a idea that's going to help us basically go from knowing something that we can measure to things that we can't even see. So we're going to be able to link like stuff we see with our eyes to this invisible sort of microscopic subatomic world that really exists below the level that we can observe. All right, so with that, let's go ahead and get started talking about the mole. Okay, so what is a mole? A mole is really just a unit in chemistry. Now, it's going to be an important unit, and it's a unit you're going to hear a lot about, but it's really just a unit we use a lot. Now, the way that we use it is we're going to start off learning how to convert between items and moles. So really when we do this chapter, it's going to be more converting problem. It's just converting with a unit maybe you're not that familiar with, but it's still going to just be converting. So the way that we convert, we need a conversion factor. And the conversion factor with the mole is that it is 6.02 times 10 to the 23 of something. Now that something could be different depending on the problem. So I'm going to say for right now, 6.02 times 10 to the 23 items is the same thing as a mole. So 6.02 times 10 to the 23 items is a mole. Now the 6.02 times 10 to the 23, really important number. You're going to use a bunch, and it's got a name. It's named after a famous Italian chemist. It's called Avogadro's number. So it's called Avogadro's number. Now, the way that we use this number again is that it allows us to convert between individual little things in this idea called the mole. So we're going to do some examples of that in just a minute. Before I do that, let me kind of try to explain to you kind of like what a mole is. So 6.02 times 10 to the 23 of anything in the world is the same thing as having a mole of that thing. So sometimes when people try to understand what this is telling me, they'll use the idea or the analogy of like a dozen, right? So like we'll get back to that number in a minute, but let's start off like what do we do with a dozen? Well, 12 of anything is called a dozen, right? 12 items is called a dozen. Now, same thing is true for a mole. 6.02 times 10 to the 23 of anything is called a mole. Those items could be anything, right? So like when we deal with dozens, where do you hear dozens? Well, like 12 eggs is a dozen. So your items might be eggs. 12 eggs is a dozen. Or, you know, maybe in another day you talk about bagels. 12 bagels is a dozen. 12 of anything is a dozen. 12, I don't know, 12 girlfriends. 12 girlfriends? That's a dozen. You got a dozen girlfriends. You're probably a little overwhelmed if you got 12 girlfriends, right? All right, so if you have 12 of anything, I could say you got a dozen. All right, so it's the same thing with this 6.02 times 10 to the 23. That amount of anything is called a mole. Now, in chemistry class, we're not going to talk about eggs or bagels or girlfriends. In chemistry class, the items that we're going to worry about are the little particles that make up the world. Now, those particles have different names depending on what kind of item we're thinking of. So the little particles inside of an element, elements are made up of atoms. So I could say 6.02 times 10 to the 23 atoms is a mole. 6.02 times 10 to the 23 atoms is a mole. Now, if so that would be if you have an element. Elements are made up of atoms. Now, if we're thinking of a molecular compound, molecular compounds are not really made up of atoms. The little particles inside of a molecular compounds are made up of molecules. So for a molecular compound, I could say let me get my color right. I could say 6.02 times 10 to the 23 molecules is a mole. So it's the same number, we're just using a different word because the little particles are called something different. Molecular compounds, the little particles are called molecules. Now the last one that we're going to run across is, we might do some examples with ionic compounds. Now ionic compounds, the little particles inside of an ionic compound are not called molecules actually. They're called formula units. So 6.02 times 10 to the 23 formula units is 1 mole. All right. So the word next to Avogadro's number, it might be different. It might be formula units, it might be molecules, it might be atoms. Why do we use different words? Because it depends on what kind of thing we're talking about. Elements are made up of atoms, so we're going to say atoms. Molecular compounds are made up of molecules, so we're going to say molecules. If we're thinking of an ionic compounds are made up of formula units, so we're going to say formula units. So we're going to do a little practicing converting between the little pieces that make up the world and this idea called a mole. Now you might be going like, why do we even care about moles? Well, the reason we do is once we kind of get used to practicing converting between little particles and moles, we're going to learn that moles relates to lots of other ideas. So it's going to help us understand how much things weigh, grams, maybe the volume of things, liters. So you have to use moles to get to a bunch of other ideas. That's going to come up in future classes. For right now, we're just going to do a little practicing like this. We're going to take moles and we're going to learn how to go between moles and particles, the little pieces that are inside of stuff. Those particles could either be atoms, molecules, oh, can't see that right there. I might have that molecules. I'll write it up here. Molecules, or they could be formula units. Just depends on what kind of thing we're talking about. All right, so let's do a couple examples. Let's flip over. We'll do a couple examples here. Oh, there we go. Okay, our first example of dealing with this new unit called the mole. All right, so this one it says, if you have 3.5 moles of water, how many molecules of water do you have? If you have 3.5 moles of water, how many molecules of water do you have? Now, this is like, it might seem a little weird. Moles? I'm not sure what that is, but it's really going to be just converting. So we're going to look at these as converting problems. That's all we're doing, really. It's just converting with this new unit that's something that maybe you're not familiar with yet. All right? So the way we're going to convert, again, let me write it down one more time here, between moles and particles, the little things that make up the world, is we use this Avogadro's number. Now, to be a little bit more exact, you could say 6.02 times 10 to the 23 of something is a mole. Now, the way that it works, again, is in that blank, we're going to write different words depending on what kind of thing we got. So it could be 6.02 times 10 to the 23 atoms. Could be 6.02 times 10 to the 23 molecules. Or it could be 6.02 times 10 to the 23 formula units. So in that blank next to 6.02 times 10 to the 23, you're going to write one of those words. Which word? It depends on what kind of thing we're dealing with. Elements, you're going to say atoms. They're made up of atoms. Molecular compound, molecules, formula units if it's ionic. All right, so in this problem, it says I'm starting off with 3.5 moles of water. How many molecules of water? So we are dealing with a molecular compound. We're dealing with wanting to know how many little molecules are in this sample of water. So again, it's just going to be more converting. So I'm starting off with moles. So I'm going to write down that beginning number and unit. Oh, I hope this sounds familiar, right? You're converting. Write down Leave a little room. We'll put a conversion factor in here. Write down the unit you're trying to go to. You're trying to go to molecules this time. You have 3.5 moles of water. How many molecules do you have? That's what I'm solving for. Now, to get from one to another, we have to have a conversion factor. Now, the conversion factor is the 6.02 times 10 to the 23. This time, because water is made up of molecules, it's molecular, what I'm going to say for my conversion factor is 6.02 times 10 to the 23. What word goes right next to it? Not atoms, not formula units, molecules. 6.02 times 10 to the 23 molecules is a mole. So next to Avogadro's number, you're going to write one of those three options, depending on what kind of thing you have. All right, now at this point, it's just converting. So how do we convert? Oh, we make sure our units cancel, and when they cancel, hopefully we'll get to the unit we want. So if I have moles here on top, where do I put moles to cancel? Oh, how did we do this again? You put moles on the bottom of the next box so that it cancels out. So I'm going to write moles down here. Now, you haven't even heard about a mole, but you kind of know how to do this problem because the units are going to tell you. Wherever you write mole, you're going to write 1. So 1 mole would be on the bottom. And then on top, you're going to put the other side of the conversion factor. So on top goes the 6.02 times 10 to the 23. 6.02 times 10 to the 23. All right, is this looking right? I hope so, because what's going to happen to moles? It's here and it's down here. Moles is going to cancel, and we'll get to molecules. All right, so with that, what are we going to do next? We're going to type this thing in our calculator, right? So it would be 3.5 times 6.02 EE. Got to do EE 23. If you do it correctly, again, you might want to just double check. You can do this right on your calculator because it's not always so easy, is it? If you do it correctly, you should get an answer of 2.1 times 10 to the 24. That's what I came up with. Did I round it? Yeah, I think I did, because this original number has 2 sig figs. So I gave you in the end a number with 2 sig figs. All right. All right, we're going to do another one. We're going to do a couple more here just to get used to this. All right, we're going from moles to molecules. Moles to, in this case. All right, so it's just converting. This is going to be your conversion factor. This is going to be your conversion factor. 1 mole is one of those. 6.02 times 10 to the 23 of something. All right, let's try another one. Let's try another one. All right, another example with a mole. All right, so let's read the question. Let's see if we can figure it out. If I have 5.8 times 10 to the 23 atoms of carbon, how many moles of carbon do I have? If I have 5.8 times 10 to the 23 atoms of carbon, how many moles of carbon do I have? All right, so first off, why are they saying atoms? Why aren't they saying molecules? Why aren't they saying formula units? They're saying atoms because this question has to do with an element. Carbon is an element. The little pieces that make up elements are called atoms. If I have 5.8 times 10 to the 23 atoms of carbon, how many moles of carbon do I have? So we're converting, right? So you write down the beginning number, 5.8 times 10 to the 23 atoms of carbon. You write down where you're trying to go. We're trying to go to moles of carbon. All right. Now, as far as this goes, let's go ahead and see. We need a conversion factor, right? So the conversion factor says, let me write it down one more time here, to go from moles to any particle. The particles have different names. Atoms, molecules, formula units. That's what I mean by particles. The way you do it is you do 6.02 times 10 to the 23 is a mole. Now, next to Avogadro's number, we're going to write 6.02 times 10 to the 23. We got to write a word. What word are we going to write this time? What word goes right here? Should be atoms. 6.02 times 10 to the 23 atoms. The question has to do with an element. We're going to say atoms. All right, so from there, oh, we got a conversion factor. We should be able to use it. Now we're just converting. We're just converting. All right, let's go and see if we can figure out what to do. We're starting off with atoms. So if you want atoms to cancel, go away, atoms. I don't want you, atoms. Where would I put atoms to cancel? Bottom. And then look at your conversion factor. Everything follows along. As soon as you write ATOM on the bottom, atoms, you write 6.02 times 10 to the 23 on the bottom. And then you got to write the 1 mole on top. It should look like this. All right, now as far as this goes, you got to get this in your calculator. Now, we haven't done a lot of math over the last couple of weeks, so I really want you to practice this. So I'm going to take a pause for a minute and type this in on your calculator. Let's see if you can get the right answer. A little pop-up. We'll see if you get it. So you got to do 5.8 times 10 to the 23 divided by 6.02 times 10 to the 23. What should you get as an answer? Here comes the question. Okay, you should be getting 0.96. If you didn't get that, try it again on your calculator. Don't forget EE, please. EE, please. You don't do times 10, you do EE. 5.8 EE 23 divided by 6.02 EE 23. And that should be your answer. All right, let's try one more just to make sure we got the hang of this. One last example in this video. Let's get to it. All right, one last example. Let's see if we can get the hang of this. So this one says, if I have 88.0 moles of NaCl salt, how many formula units do I have? So why are they using the word formula units? Okay, so now we can convert, right? So this is a converting problem. So we are going to go from, well, it's just converting, right? Write down your beginning number and unit. 88 moles of NaCl. We are going to formula units of NaCl. So write down your beginning number unit, write down the unit you're going to, and in the middle here, we have to put a conversion factor. So I kind of have, it start on the bottom. Let's remind ourselves, moles to particles. Moles to particles. This time the particles are not atoms, not molecules. They're formula units. So that's what we're trying to do. Could be atoms in another problem. Could be molecules in another problem. But for right now, it's formula units. So to get from one to the other, you use Avogadro's number. 6.02 times 10 to the 23 equals 1 mole. 6.02 times 10 to the 23, there's going to be a word here. Not atoms, not molecules. Should be formula units. 6.02 times 10 to the 23. So one of those three options goes next to Avogadro's number is a mole. All right, so at this point, I think we're in pretty good shape. We got our beginning number, 88 moles. We got what we're trying to solve for, formula units. And we got our conversion factor. All right, let's just use it. Moles are on top. So where does moles need to go to cancel? On the bottom. So you would put mole down here. Now let's take a look at that conversion factor. 1 goes on the bottom. Then Avogadro's number goes on top. 6.02 times 10 to the 23. It should look like that. Formula units. Should have left a little more room there. All right. Well, if you work it out, 88.0 times 6.02 EE23, you should be getting this. You would have 5.30 times 10 to the, what I get, 25 formula units. All right. So with that, I think that's all the practicing I'm going to do on this one. So we've done a lot of, well, not a lot, a few examples, right? Going back and forth. Moles and particles. Particles are either formula units or potentially atoms or potentially molecules. Now, I should tell you, this is not all we're going to do with moles, because if this is all we could do with moles, it really wouldn't be super helpful. So as we're going to see in the next video, moles connects to other ideas. So that'll be in part B of this lecture. So how does mole relate to other things as well? All right, so if you have any questions or you're mixed up on this, please contact me. I'll try to answer some questions, help you out. And with that, let's scoot on to part B.